want to spend the first 20 minutes talking sort of, I guess, about the Penn World Tables and related data sets and the facts of economic growth. So kind of a big picture overview of some of the important facts of growth. And then for the second 20 minutes, look at the US Census data and American Community Survey and some work that I've done with Pete and Cheng Shea and Eric Hurst and Jean-Felix Brouillet, a graduate student at Stanford, on, in some sense, the misallocation of talent. So Pete talked about misallocation a lot at firms, and this will focus on misallocation at the individual person level. Okay, but for the first part, let me talk about the facts of economic growth here. Yeah, so facts, and then I used MATLAB, and so I made the MATLAB code available for reading the Penn World Tables or for reading the census data, and I'll spend a minute or two at the end of each of these halves talking about that code a little bit. Okay, so the first part of this comes from this Handbook of Economic Growth chapter that I wrote several years ago. Here's just sort of, one way of looking at many countries or regions in the world, GDP per person relative to the United States. So in every year, we let the US be 100 and ask how rich or poor are other countries relative to the United States. And so you can see Japan and Western Europe there at the top, where, from 1980 to 1985, maybe they fell slightly further behind. Maybe that was due to rapid growth in the United States, right? But then the numbers are something like, 65 or 75% of the US. And then, Japan obviously was growing really rapidly before this period, and then that continued into, basically 1990. So you can see Japan moving up to actually 85% of the US, and then falling back. And by, for the last 15 years or so, both Japan and Western Europe have had income per person that's roughly 75% of the US. So a point I'll come back to at the end of this first 20-minute session is, wow, France and the UK don't seem to be 75% of the US. Is that really right? And how do we think about that? But, sort of 75% is the number that comes out of the Penn World Tables when you look at GDP. You could see Brazil there, Russia there, China, obviously, China and India, two countries that are very interesting from a growth standpoint, just because they've exhibited such rapid growth recently, right? So you can see China starts in 1980 at about 7% of the US and ends up in 2017, I think, for this graph, at about 25% of the US. So you remember, China has 4 times as many people as the United States, and it has 1/4 the GDP per person. So total GDP, aggregate GDP in China and the US, in purchasing power parity adjusted, so using the same prices to compare them, they're about the same size right now. But on a per capita basis, China's 1/4 of the US. But going from 7 to 25% over the course of this 40-year period, that's what 7% growth per year does for you, right? So that's what 7% growth per year looks like there. India starts out further behind at some number like 3, and from some of Pete and Cheng's work, for example, you remember that there were big reforms in the early 1990s and continuing, and so you could see India kind of lagging China a little bit, maybe by 10 or 15 years, but now in 2017 here, reaching about 11 or 12% of the US. And then finally, Sub-Saharan Africa, you see kind of a different pattern here, which is in 1980, Sub-Saharan Africa as a region had about 10% or 11% of the GDP per person in the United States. That they fell further and further behind. So in 2000, this number was more like 4%, right? So this is another way of saying the United States grew faster in GDP per person than Sub-Saharan Africa as an entity. But that switched after 2000. You could see they went back up to 7 or 8%. So this sort of is one way of seeing the broad growth patterns across a range of countries. Here's another graph that I'm showing you that shows similar data, just differently. On the horizontal axis is GDP per person on the in 1960. On the vertical axis is GDP per person in 2017. Right, and so you can see a bunch of interesting things in this graph. Maybe one big picture point let me make now, because I'll come back to this a little bit later as well. Imagine I hadn't labeled the countries, so you just saw the blue circles. the graph would be much less informative. So whenever you have a scatter plot like this, you should label as many circles as possible. And I have some MATLAB code that I've given you, plot name sim2, that will do this automatically for you. With overlapping labels, it's not good. So when we're publishing a paper, I'll go in and clean out, cut out some of the labels that are overlapping. So I've got a routine that does a little bit of selecting where to put the label, but it's not great. So label your data. I care a lot about the quality of the figures. You want to communicate as clearly as possible, and that'll hopefully come through in my presentation. So what else can you see here? So everything's relative to the United States, being one in both of these periods. You can see Switzerland and Luxembourg are kind of richer than the United States. Ireland, famous for the way profits are repatriated into Ireland to avoid taxes. Singapore is very rich as well. Norway as well. If you look at the poorest countries of the world in 1960 versus today, interestingly, look at the scale of the axis. It cuts off at 1/64th of the US in 1960, and it cuts off at 1/128th of the US in 2017. And that's sort of another way of saying an interesting point, which is the gaps between the richest and poorest countries have gotten bigger over time, not smaller, but that counts by country instead of by person. It turns out those give you different views of the way world inequalities change. So I'll come back to that point in a second. Obviously, countries that are high above the line here, this is a 45-degree line that I've got in blue. If you're high above the line, you've grown, you've increased. You've grown faster than the United States. You've increased in this graph in the position. And if you're below the 45-degree line, you've grown more slowly than the United States. So you've fallen behind the United States. And you can see there are a bunch of countries in both of those groups. So 2% growth of GDP per person in the United States, which you might think of as something like, what should be possible to everyone, even at the frontier. A bunch of countries fall short of that. A bunch of countries have done better than that. Okay, hold on one second. I'm going to change what I want to do here. I'm not sure I can totally see if you raise your hand. So if you have a question, raise your hand. I think I'll notice now. I think I just moved something around so I can see. Okay, here's another really cool fact that Alex Bick, David Lagakos, and Nicole Fuchs-Schindel and Timo Boppart and Per Krusell have all made a big deal out of in some recent papers. And that is, as countries get rich, eventually their average hours worked starts to decline. Okay, and so you could just see this in many, many countries, and they have data. The Bick, Lagakos, Fuchs-Schindel paper emphasizes microdata. Boppart and Krusell use more sort of existing summary data across countries, but going back really far in time. So this is a very robust fact. You can see it's not always an everywhere issue. So South Korea, when it first started growing rapidly, workers in South Korea started working harder. But even in South Korea, where they were working more than 2,800 hours per worker by the end of the 1980s, it's plummeted a lot. So down to 2,200 or even less. But you see the same pattern in Japan and France and the UK, and even in the US. The US is one of the smallest declines, I would say, in hours worked. But the 2,000 hours per worker in 1950 now looks more like 1,800 hours per worker today in the United States. So thinking about what's behind these broad patterns, I would say, and this is a hint you can see in a lot of my papers, probably half my research papers have the following character: identify a key fact in the data that no one's going to argue with, like this fact, we're not going to argue with it. It's true, it's robust. And then ask, well, can you write down a model where that happens? And does that model have extra implications that might be interesting? Can you make it happen not just qualitatively, but quantitatively? And what explains why people in South Korea work so much harder than people in Japan? And what explains the upward trend and then the downward trend? These, looking at trends and try to explain them is half my papers are kind of that character, I think. And so that's a way I like to do research. So I'm infatuated with graphs like this, I would say. Okay, I mentioned before that, when you look at the country level, it looks like the rich countries are even richer than the poor countries. The gaps have kind of widened. So global inequalities increased if you look at the country level, but it's certainly not true at the individual level. And that's a really, really important point. This graph, I would say, because growth economists don't typically look at the individual level, we don't emphasize it as much as we should, but it's probably, like the first graph you should show in any class on economic growth in some sense. So what is this graph? So horizontal axis is GDP per person relative to the US being 1 in 2017. So I'm going to show you data for 1960 and 2017, but the US is equal to 1 only in 2017. Okay, so the US would be I don't know, a factor of 3 poor. The US would be 0.33. Is that right? Yeah, I think that would be right. US would be 0.33 in 1960. So that's where the US is, right up here. Good. Okay, so what do you see? So what I've done here is I've assigned each person in every country their own GDP per person. So you can see China and India are these big jumps. And the vertical axis, sorry, I should have said this already, this is what fraction of the world's population lives in countries with GDP per person less than whatever the number is on the horizontal axis. Okay. And so, I've written the summary here to help remind me what to say. In 1960, 2 out of 3 people in the world lived in countries with GDP per person less than 5% of today's US level. So less than about $7 per day. And so if we go to where the 2/3 point is, right in here, right, you'll see that's at about 1/12 of the US, in income, I think. Sorry, 5%, I want to be 1/20th, right? So down here, probably. I'm not good at drawing my lines across. All right, so two out of 3 people in the world in 1960 were very, very poor. What fraction of the world's population today lives at that same level, $7 per day, or less than 5% of today's 2017 level? The answer is only 1 out of 12, right? And so the point that was here is now way down here. And you can see, a big part of that is China and India with, kind of, 2.5, 3 billion people in the world. As China and India grow rapidly, that's lifted 2.5 or 3 billion people out of this extreme poverty. And, that's an incredibly impressive achievement, right? So at the individual level, there's been a decline in global inequality, even if at the country level, there hasn't, there's been an increase. But I think the individual level is kind of, in for this question, what we care about. So as I mentioned, this treats each person within a country as having the same income, which is obviously not true. You could do better, and various people have tried to bring this to the data as well, using some of like the World Wealth and Income Inequality database. Xavier Sally-Martin, Martin Ravillon, various other people have sort of added within country inequality to this graph, and it just reinforces the point basically. So the changes in within country inequality are small relative to these big gains in income per person that we see in places like China and India. Okay, now I want to shift gears to a paper with Pete. I think this, these first 2 hours are, all about Pete's papers, I think is one way to look at it. This is a paper where we did the following. Go back to that France example, where I said, France turns out to have about 70% of the GDP per person in the United States. And if you looked at consumption per person, it would be about 65%. People in France are surprisingly poor when you just look at their consumption. And, when I go to France, France seems like it's a pretty successful country and has some things to like about it. So is there something wrong with the GDP numbers is kind of partly the motivation for this. And when you look at the data, one thing you appreciate is that sure, France has low consumption, but France has high life expectancy. People in France live about 2 years longer than people in the United States. They don't work that hard, but that means they have a lot of leisure, right? So people in France have more leisure than the United States, and inequality is lower. So behind the veil of ignorance, you're going to be born as a random person in the United States or France. Where would you rather be born as a random person? Well, the inequality piece of it, if I said you're going to be a poor person, you'd rather be a poor person in France, I think. And so the inequality is going to be bigger in the United States, and behind the veil of ignorance, we'd like some insurance against that. So that's in some sense a reduction for the US as well. So what we do in this paper is we write down a standard utility function, the kind that economists use to study, asset pricing or exchange rates or international trade or business cycles or everything else, labor supply. Write down a standard utility function that also includes years of life. So you add up over your years of life, your U of C comma L, and your consumption is uncertain, your leisure might be uncertain as well. And so, we take that inequality into account. We ask, what's the consumption equivalent welfare? Put everything in consumption units. How much would you have to give up, take away from a French person to have them suffer the low life expectancy in the United States and be indifferent there? So that's the kind of question we're asking. And what you can see in this chart, on the horizontal axis is GDP per person, US equal 1. On the vertical axis is the welfare number. I realize I'm going too slowly, right? I need to speed up. And they're highly correlated. So the correlation is 0.95. So the first thing is, sure, all these other things matter, but GDP per person is a good summary statistic. There's a reason why we use it. But that's not the entirety of the story. And if you look closely, you can see a bunch of rich countries are above the line, and the poor countries are disproportionately below the line. And so the gaps are large. So on the vertical axis now, the horizontal axis is the same. On the vertical axis, I have the ratio of welfare to income. So how much higher is consumption equivalent welfare than the income comparison would suggest? And look at France, for example. France is about 30% richer than their income would suggest. And so instead of being 65% or 70% of the US, France is going to look like 90 or 95% of the US in these calculations. And you can see the UK, Sweden, are going to be like that. There are other countries, poor countries of the world. Most of the countries are below the 1, and so there are many countries that get deductions. Okay, so let me show you some of these, picking out some of the countries to show you what's going on. So life expectancy, the actual numbers for the variable life expectancy in the US is about 78 years. Our consumption to GDP ratio is about 85%. Hours worked in the US, not per worker, but per person, is 836. So this is the opposite of leisure in blue, but it's the leisure adjustment. And then consumption inequality, the standard deviation of log consumption in the US is something like 65, 66%. Okay, so now France, GDP per person for 2007 here was 70% of the US. But as I said, people in France live longer. I guess it's 3 years instead of 2 years. They have lower consumption, right? I already said that. They work less, 600 hours rather than 800 hours. So that's a lot less work and a lot lower inequality. Standard deviation of log consumption, 47% instead of 66%. How much is each of those worth? Well, interestingly, the inequality adds 10, lower inequality adds 10%. Higher leisure only adds 6%. You might think maybe it should add even more. Maybe we're being conservative here, right? 600 hours versus 836 hours, but it only adds 6 or 7% with our standard preferences. Longer life expectancy, each year of life is worth about 5% of consumption, right? So 3 years gives you about 16%. When you add all those things up, France looks like 90% of the US rather than 70% of the US. Let me go down again in the interest of time. Let me pick a very poor country like Botswana, which doesn't look poor when you look at their GDP, 25% of the US, one of the richest countries in sub-Saharan Africa. But when you look, they have lower life expectancy, much lower because of AIDS in this period, 52 years versus 77 years. Remember, each year of life is worth about 5% of consumption. So this knocks off 77 log points, right? They work slightly harder, and there's even more inequality in Botswana. And the inequality reduces consumption equivalent welfare by 33%. So instead of looking like 25% of the US, instead of being pretty impressive, on a consumption equivalent welfare basis, Botswana looks even poorer, like 5% of the US. And we find this in general. So Western Europe looks closer to the US because you add in their longer lives and their higher leisure. The poorest countries of the world look even poorer when you do things this way. Okay, Let's see, what do I want to do? I love these facts. These are my new papers. So these are graphs I added.
Chad, I would suggest that you keep going and you take a few extra minutes because we do have some margins.
Okay, yeah, as Pete said, I think I get too excited and put too many things in here. Okay, great. So another cool fact about the world, which you might not appreciate, ask yourself, what happens to global population 100 years from now? Does it level off? Does it keep growing? Well, if you'd asked me a year and a half ago, I would have said my guess is it's going to level off at, like, I don't know, 8 or 9 billion people, something like that. It turns out all of the rich countries in the world have fertility rates below replacement. Okay, what do I mean here? How many kids does each woman have on average? And 2 kids per woman on average would be replacement. That would be maintaining a constant population. If you look at the high income countries as a whole, they have 1.7 kids per woman. The US is 1.8, China 1.7, Germany 1.6, Japan, Italy, Spain, even less. So, and as countries get richer, the fertility rates decline. That's a fact that you probably knew. What I hadn't quite appreciated, you might have thought, well, they level off at 2 somehow. But as soon as you say that, you realize, well, there's nothing special from an individual family standpoint about 2 kids. And in fact, when we look at India, they used to have 6 kids per woman, then 5, then 4, then 3, and now 2.5. You could see they're headed for this 2. And you're not going to stop necessarily. And if we look at all the other countries in the world that have gotten rich, they haven't stopped. They've gone right below 2. So I have a paper that I won't talk any more about, but it's called The End of Economic Growth. So the growth models I like, population plays a very important role because people produce ideas. So if actually the future of global population is that it's declining because we're having fewer than 2 kids per woman, that might actually lead to, well, it's The Empty Planet, the book that I took these facts from. There's a book that had the title Empty Planet, but it actually leads to the end of economic growth as well. And so you can have this stagnation of living standards on a planet that gradually empties of people. And this is a very different view of growth from our standard view, where we say you have exponential growth in living standards for a population that grows exponentially, right? That's the view I had of growth before I worked on this paper. And now I realize, well, it's not quite so clear. Finally, there's some growth accounting. This is another new thing that I've done that kind of lays out where does growth come from. And this one I think I will skip because I'm taking time from my next session now. So I mentioned these programs are available. There's a collection of subroutines that I've written called in chadmatlab.zip. And here are the key programs that you need to read the Penn World tables and to make the graphs that I've made. And it shows you how to label the countries. And here's some code to help your graphs look nice.